Today's video is on integration using residues. In today's video, we are going to find the poles and the corresponding residues of the given function 1 by z square minus 1 whole cube. See here clearly from the question, what is f of z given? So f of z is given as 1 by z square minus 1 whole cube. So this can be written as a square minus b square. So f of z can be written as 1 by, this is z plus 1 into z minus 1 whole cube. So this is whole cube. Now f of z is equal to, see, f of z can be written as 1 by, this is z plus 1 whole cube into, this is z minus 1 whole cube. Now, see here, in order to find the poles, we have to equate the denominator to 0. So, if I equate the denominator to 0, then z plus 1 whole cube into, this is z minus 1 whole cube is equal to 0. So, if I equate this z plus 1 whole cube to 0, see, so z value is equal to minus 1. So, we got a pole of order, so pole of order 3. Clear? And next, if I equate this z minus 1 whole cube to 0, so we got the value of z as 1, and which is a pole of order again 3. Clear? Now we got the pole values as minus 1 as well as plus 1. So these are the pole values. Now what we have to find? So after finding the poles for the given function, we have to find the residues for the corresponding pole values. For finding the residue value, see, here is a formula, that is residue of f of z. See, residue of f of z at point z is equal to z naught is equal to, see here, this will be 1 by m minus 1 factorial into limit z tends to z naught. This is d by dz power m minus 1 into, this is z minus z naught power m into f of z. Clear? And here in this, so m value will be, so m is the order value here, so m value is equal to 3 and z naught value is equal to, see here, this one, the pole value will be the z naught value. So if I substitute each and every term here, then the residue of the function f of z, see here, residue of f of z at point z is equal to minus 1 will be 1 by m value is equal to 3, that is 3 minus 1 factorial into limit z tends to, what is z naught value? The pole value, that is d by dz terms of m is equal to 3, that is 3 minus 1 into, this is z minus, so here z naught value is minus 1, so minus of minus plus 1 power m value is equal to 3 into f of z. So what is our f of z value? F of z value is nothing but 1 by, this is z plus 1 whole cube into, this is z minus 1 whole cube, z minus 1 whole cube. So if I cancel this for one time, see, this will be, that is 1 by 2 factorial into limit z tends to minus 1, that is d by dz square into 1 by, this is z minus 1 whole cube. So we have to make derivatives for 2 times, and again we have to substitute z value as minus 1. So this will be 1 by 2 factorial into limit z tends to minus 1. So if I make derivative for one time, so this will be minus 3 by z minus 1 power 4. Clear? And again if I make derivative for another time, so this will be limit z tends to minus 1. If I make a derivative, so this will be minus 3 into minus 4 by, this is z minus 1. So z minus 1 power 5. So if I put minus 1 here, so this will be 1 by 2 factorial into, already this is 12 and this is minus 1 in place of z as minus 1. So this is power 5. So if I cancel this with the 2 table, see here, so this will be 6 by minus 2 power 5, so which is equal to 6 by minus 32. And here if I cancel this one in 2 table, this will be minus 3 by 16. So minus 3 by 16 is the residue value for the corresponding pole z is equal to minus 1. So here I'm writing clearly. The value here I got is minus 3 by 16 after cancellation. So I got the value as minus 3 by 16 for the pole value z is equal to minus 1. And the next one here, the pole value is z is equal to plus 1. For z is equal to plus 1, again we have to substitute here in this formula. So this is the formula in which we have to keep the order value m as 3 and the pole value z naught as plus 1 now. Now this is plus 1. So if I substitute, see what happens here. So this will be residue of f of z at point z is equal to 1, which is equal to 1 by, this is 3 minus 1 factorial into limit z tends to, z naught value is 1, and this is d by dz value of m is equal to 3, which is equal to 3 minus 1 into z minus z naught value is 1 and m value is 3 into f of z. So as you know that f of z value is this one, that is 1 by, this is 1 by z plus 1 whole cube into z minus 1 whole cube. Now I can cancel these two and I have to make a derivative for 2 times, and again I have to substitute the z value as 1. So this is 1 by 2 factorial into limit z tends to 1 into d by dz square into this one is 1 by, this is z plus 1 whole cube. So this value is equal to 1 by 2 factorial into limit z tends to 1. So this is d by dz times of, the derivative of this one is minus 3 by, this is z plus 1 whole power 4. And the next derivative here will be, so this is 1 by 2 factorial into, this value is limit z tends to 1. This value is minus 3 into minus 4 by, this value is z plus 1 power 5. Clear? Now I have to substitute z value as 1. So this is equal to 1 by 2 factorial into this value is 12 by 1 plus 1 power 5. So 2 factorial is again equal to 2, and this is 12 by, this value is 2 power 5. So if I cancel into table, this is 6, this is 6 by 2 power 5 is 32. So if I again cancel in 2 tables, so this is 3 and this is 6. So the value here is 3 by 16. So now the residue value of f of z at point z is equal to, at the pole value z is equal to 1 is 3 by 36. So we got the residue value of the function of, at the pole z is equal to 1 is 3 by 16. So let me explain you once again. See here, the question given here is we have to find the poles corresponding and corresponding residues of the function 1 by z square minus 1 whole cube. So here we have to take f of z as this one. So this can be written as a plus b into a minus b, that is z plus 1 into z minus 1. So again, if we want to find the poles, we have to equate the denominator to 0. After equating, we got z value as, the pole value as minus 1, which is of order 3, and pole value as 1, which is of again order 3. So for order 3, so this is the formula. So in this formula, we have to keep the order value as m and the pole value as minus 1. So after substituting and deriving for 2 times and substituting z value as minus 1, we got the value as minus 3 by 16. And for the next pole value z is equal to 1, the same formula I have applied. So in this formula, if I keep m is equal to 3 and z naught is equal to 1, and f of z value is also clearly given here, and after cancelling numerator and denominator and deriving for 2 times and keeping z value as 1, see here, this is the final value. This is the residue value for the corresponding pole value z is equal to 1. Thank you so much for watching. If you really understand this one, please practice, pass it on to your friends and subscribe to this channel. Thank you so much.